I'm going to give a little lesson on how you calculate the cross product of two vectors. And in order to understand that, you need to understand how to calculate determinants. So I put this formula for 2 by 2 determinant. You should already be familiar with this formula, and what it represents. This actually isn't essential in order to solve these problems, but I just want you to know what it represents is the area of that parallelogram. Now I'm going to do a little example where I calculate the determinant of a 3 by 3 matrix, and that represents the volume of this object, which is called a parallelepiped. That's kind of a cool word. This vector right here should go along this axis. This vector right here should be pointing up at that corner right there, and then this vector right there is going to point back at that corner right there. And once you know and then it's always the origin down here in the corner. And once you know the location of those three corners, then you can calculate the volume of this parallelepiped. And this is the way that you do that process. So the way it works is you turn this 3 by 3 determinant into a bunch of 2 by 2 determinants that are all called minors. So this calculation process is called expansion by minors. So we always use this top row here, okay? Actually, you can pick any row or column that you want, but for the purposes of Calc 3, we're just going to stick with this top row. So what you do is you pick the first entry, and then you cover up the row and column that it goes in. And then you put that coordinate out front. So I took that 3 and I put it right there. And then you put the determinant of the remaining piece in the side it left over. So this is going to be 4, 7, 11, negative 2. Okay. And then you just continue down the rows and column, or this first row here in this way. So now I'm going to pick the next one and cover up the row and column that he lives in. So I'll put the 2 there, and then I just use this determinant of the piece that's left over that I can see. So negative 1, 7, negative 3, negative 2. Okay, and then there's one more, right? What about this 5 right here? So I'll put a 5. And then you cross out the row and column that they come from, and you use the determinant of the piece that's left over. So negative 1, 4, negative 3, 11. And then the pattern always goes plus, so the 3 is whatever you want, is whatever number goes there, and then minus, and then plus. So you always just keep the number, you change the sign of the one in the middle, and then you keep the number at the end. So this is how you expand by minors, and then from there, we're just going to use these little 2 by 2 determinants to fill out the last piece. So let's just get after that. So this will be 3 times, now I'm just using this AD minus BC rule, so negative 8 minus 77 minus 2, so this will give me 2 minus a negative 21, and then 5, and this will be negative 11 minus a negative 12. Okay. So now you just crunch out this arithmetic here, and that gives you the answer. So I ended up with negative 296. I might have done that wrong. You know, sometimes these numbers just come out a bit crazy. So let me know if I did this arithmetic wrong. That's how expansion by minors works. Let's use this to calculate some cross products. Okay, I've cooked up some vectors here. I just picked some random numbers to just throw in the positions. And we're going to use determinants to calculate this cross product of U cross V. So what you do is you set up a determinant of a matrix. You always put I, J, and K along the top row. and then it's u cross v. So the first thing I need to do is put the vector u, and then v comes second, so then I'm going to put v down here. And then all you need to do to calculate these is to expand this determinant by minors. So I'm just using the expansion by minors formula here. So I'll start off with I. This is kind of nice because when you cover up the first row and the first column, you're always just covering up those i's and j's and k's at the top there. So I'm covering up the ijk row, and I'm covering up this first column. And then inside this minor, all you do is you put the numbers that are left over. Okay, remember it always goes plus, minus, plus. So next comes j, and then I need to cover up the row and column that j goes in and just use the numbers that are left over in the minor. So -2, 0, 5, 1. And now just one more here with k at the end. So I'm going to cover up this row and this column, and I'm just going to use the numbers that I see there. So -2, 3, 5, -7. Okay. All right, so after you expand it by minors, all you have to do after that is just work out what each of these little determinants is just by using that AD minus BC formula. So let's do that here. It's going to be 3 times 1 is 3 minus 0I minus, okay, now this will be -2 minus 0J, and then this one will be 14 minus 15K. Okay, so we're almost done there. So then you get 3I. Okay, so this is plus 2J, and then minus 1K. So if you want to write this in the kind of math student way with chevrons there, you could write it like that. So that's the way that you calculate the cross product. This is a vector that is perpendicular to both of these vectors, and it follows the right-hand rule. That's how you figure out which way it points. Okay, I'm going to work out an example problem here where we're asked to write the equation of a plane, and we are given 3 points. So I've copied down here the general form for the equation of a plane, and the important thing here is that these numbers A and B and C, those all come from a vector that is perpendicular to the plane. So our goal is to find n. Basically, that's the hard part of writing the equation of a plane. Once you know what the normal vector is, then it's easy. You can just plug everything else into the formula. So let's jump into that. I can do that because I can produce vectors that's in the plane. Let's find vectors in the plane. So I'll call this, I'll call it U for vector. And I can just pick any one of these points. I can just do final minus initial, and that will give me a vector that's in the plane. So I'll choose this one and this one. The important thing is that you just make sure that you use all 3 of the points at least once in this process. So here I'm using the first 2. So I'll do final minus initial here. Okay, so 0 minus 1 is -1, -2 minus 0 is -2, and then 1 minus -3 is 4. Okay, that was fine. So now let me pick another point in the plane, and I can just pick any other pair of these that I didn't already use. So I already used these 2. So let me pick some different ones. I pick this one and that one there, for example. So I'll do final minus initial for this one. So 4 minus 1 is 3. -5 minus 0 is -5. And then 7 minus -3 is 10. Okay, so just to recap there, what I did was I picked 2 points, and did final minus initial, and that gave me a vector that's in the plane. And then I picked another 2 points and did final minus initial, and that gave me a vector that's in the plane. And the only thing that you have to remember to do is to make sure that you use all of the points at least once. Okay, so you're not like allowed to just use the first point and the second point, and then again use the first point and the second point. That isn't going to work. So you got to make sure that you use all 3 of the points. Okay, so both of these vectors are in the plane, and our goal is to find a vector that's perpendicular to the plane. So that's exactly what the cross product does. Given 2 vectors, the cross product finds a vector that's perpendicular to them. So this means that the normal vector is going to be u cross v. And there's a lot of freedom here. You know, there's a lot of vectors that are perpendicular to the plane. I could have chosen different points, and I could choose to do this cross product in a different order. It's kind of cool about math that it's guaranteed to give you the right answer. So let's just set up this cross product here. So I, j, k. I hope I'm doing all my arithmetic right. So now I'm copying in the pieces. Okay, and now I'm ready to calculate this cross product using expansion by minors. So it's going to be I times the determinant here. Whoops. -2, 4, -5, 10. Right? When you do I, you cross these out and you use this one. Okay. Minus, remember it goes plus, minus, plus. Minus j, and then I'm going to use everything except for the one that j is in. So -1, 4, 3, 10, plus k, and then this will be right, everyone except for the row and the column that k is in. All right, so what do you get here? Okay, so I just expanded these little pieces by minors there, and that gave me this vectors 0, 22, 11. So just to recap where we're at with this, what we did was we had 3 points in the plane, okay? And then I used those 3 points to produce vectors that were in the plane. So I've got a plane, and I've got 2 vectors that are in the plane. And what I need is a vector that's normal to the plane. So I need a vector like this that's normal to the plane. So that's exactly what the cross product is for, right? If you have 2 vectors, then the cross product produces another vector that's normal to the plane. So that's what I did next. And then I did this cross product, and that gave me this vector right here, which must be this vector that's normal to the plane right there. So that's where we're at right now, and then everything is already just set up for us to plug it into that formula. So let's do that, and it will give us the final answer. Okay. So I'm just setting this up to plug everything into that formula there. The only issue is I need an x naught, a y naught, and a z naught. And you can choose any one of these points. It doesn't matter which one you choose. You'll get the answer correct no matter what. I'm going to choose this one down here at the end, just arbitrarily. You can pick any one. So here's the final answer. 0 times x minus 4. Plus 22 times y plus 5 plus 11 times z minus 7 equals 0. Okay, so let's just trace these pieces through. Let's sort of follow them around so we can see where they all go. So here is where the components of the normal vector goes. And there is where all of the points in the plane go. Okay. All right. I hope this makes sense to you. I'm pretty sure that there's a problem like this in the homework. So, you know, go in there and give it a shot. And let me know if you get stuck or if you have any questions. See you guys next time.